Hello everyone. Today we are going to study about vector valued functions. So what are vector valued functions? We will talk about those functions whose values are vectors. So let me first take an example. Let me start with the simple one. Let's say we have a function y equal to x plus 3. Let's plot this. So this will be a straight line, of course, y equal to x plus 3. So the straight line looks like this. So this is our curve, right? Y equal to x plus 3. So this is our curve. Now for a particular value of x, let's say x equal to 1, you will get a particular value of y. So y becomes 1 plus 3, 4. So for x equal to 1, you are getting y equal to 4, which is our functional value. So our functional value is 4, which is a scalar. Mark my word, which is a scalar. Now for a particular value of x equal to, let's say, 2, you are getting a functional value of y equal to 5. So this is also a scalar quantity, right? So we are getting some points 1 comma 4, 2 comma 5, and you will get a lot of results. If you put x equal to 3, you will get different answer. So this will go on. Now let me write the same equation but in parametric form. So we can write this in this manner: x equal to t, y equal to t plus 3. Here t is our parameter. So we have written the same equation but in parametric form. Now this is same as this. Let's check it out. If we put t equal to let's say 1, then we get x equal to 1, y equal to t equal to as 1, then 1 plus 3, it will become 4. So we are getting 1 comma 4, like we are getting 1 comma 4 there also. Now if we put t equal to 2, you are getting x equal to 2 and y equal to 5. So you are getting 2 comma 5. You are getting the same result here. So this is same as this. Now let me remove it. So this is our parametric form. Now I am going to write this in different manner in vector form. Look very carefully. Now I am writing this function like this way. Here x equal to t, that means x is some kind of function of t. Here y equal to t plus 3, again y is some kind of a function of, let's say, g of t, function of t. This is a function of t also, and this is also a function of t. Now we can write r of t equal to ti plus t plus 3j. We have written t plus t plus 3j. We have written this function in vector form. Now if you put t equal to, let's say, 1, let's start with 0. If we put t equal to 0, then we will get r of 0 equal to 0i plus 3j, which is a vector, of course. Now if we put t equal to 1, then we are getting r of 1, 1i plus 4j. Now again, if we put t equal to 2, we are getting r of 2, that means 2i plus 5j, and this will go on. Now look, now I am writing the same graph. So this was our curve. Now listen to me very carefully. If t equal to 0, then we are getting 0 plus 3j. That means this is a vector. If we plot 0 plus 3j, this will look like this. This is our 0 plus 3j vector. right? Now if we put t equal to 1, then we are getting this vector 1i plus 4j, and this will look like this 1 plus 4j. If we put t equal to 2, then we were getting 2i plus 5j, and this simply some kind of vector looks like this. Now if you put t equal to 3, you will get a vector like this, and if you put t equal to 4, you will get some kind of vector like this. If we put t equal to -1, some vectors like this. Now what I'm trying to say is, look, the red curve, the curve is getting generated by some vectors, right? The curve are traced out by the terminal points of the vectors formed by the functional values of f and g, right? Look, the red curve is getting generated by the terminal points of these vectors, right? So now this form is called vector valued functions. Let me mark it. So this form is called vector valued functions. Why this is a vector valued function? Because for each point we are getting a result as a vector, right? This is 3j vector, this is 1 plus 4j vector. Each point represents here a vector, so that is why it is called vector valued functions. Like before, if we put x equal to 1, we are getting a function value of 4, which was a scalar. But in this example, if we put t equal to 1 or 0 or 2, we will get different kind of vectors which will result the curve. So as the inputs are vectors, this is called vector valued functions. For 2D, we like to write our functions in Cartesian form, but for 3D it is more convenient to write the functions in parametric form, because writing in parametric form is very much easier to understand the curve. Now let's take another example. Suppose we have, let's say, x equal to 1 minus t, y equal to 3t, z equal to 2t. Now it is some kind of hard to relate x, y and z together. Instead of this, we can simply form it in a parametric form. Here t is our parameter, so writing it in parametric form is much more easier. So we have written this 3D equation in parametric form. Now this will represent a straight line but in 3D form. I cannot write the 3D structure in my 2D board, so let's take help from a software which is GeoGebra 3D calculator. Now let me give the input. So our x equal to what? 1 minus t, 1 minus t, y was 3t comma 2t. Look, this is our straight line, but it is in 3D form. Look, this is a 3D plane. The black one is our function. Look, this is in 3D form. Very carefully. Look, this is how a 3D function looks like. This is a simple one. Now we can generate this function by some vectors, right? So the vector form of this function looks like this: r of t equal to 1 minus t I plus 3t j plus 2t k. This is our vector value functions. Now if you put t equal to 0, then r of 0, you will get a vector, right? Here the vector becomes 1i plus 0j plus 0k. Now if you put t equal to 1, you will get another vector. If you put t equal to, let's say, 1.3, you will get another vector. Now the curve is getting produced by some vectors. That is why it is called vector valued functions, right? Now some vector valued functions are not as much simple as that. Let me draw this. Look, this is a circular helix. It is hard to draw in 2D. Look very carefully. This is a circular helix. So that was it. Thank you for watching.